We are in the district of Yusufeli, 78 kilometers from Artvin. Behind me is the Çoruh River, bringing life to Artvin, and is one of the fastest flowing rivers in the world, holds a large part of our country's hydroelectric potential. From here, it's planned to build 17 hydroelectric power plants in total on the Çoruh River. 7 of these dams started the production, and 1,318 gigawatts-hour of electrical energy targeted to contribute 4.5 billion Turkish liras to the economy of the country and greatly reduces our country's external energy dependence. In a minute, I will introduce you to the greatest of these projects. Health and safety was accepted as the first priority on the construction site, where the risks were also high due to the geographical conditions. Due to large risk in construction site with the impact of geographical conditions, an expert team assembled only for job safety monitored every area of the field for 24 hours, took precautions above the world standards since day one, and ensured that all risks are minimized 117 days, and the riverbed was shifted in 2014. Later, in order to carry out operations such as foundation excavations, body construction activities, the downstream cofferdam and the dam side made suitable for body construction activities. Due to difficult and heterogeneous geological surface in such a steep location, it was not possible to reach the starting points of slopes with open field excavations in order to start body construction. Thus, transportation to right bank slope at EL 400. Due to difficult and heterogeneous geological surface in such a steep location, it was not possible to reach the starting points of slopes with open field excavations in order to start body construction. Thus, transportation to right bank slope at EL 450 from foundation elevation and transportation to every 15 meters above the crest was provided with helix-shaped tunnels having 17% inclination. All staff, equipment, and machines are transferred via these tunnels, and the excavation began. From this point, the foundation elevation was reached by excavating 450 meters. When the excavation activities started, a 3-line crane system was manufactured specially for the dam site, as vehicle supply cannot be conducted to the site with regular ways. Machines and other equipment was transported through these cranes. Each line in this crane system has 28 tons of load carrying capacity. When these cranes are working in synchronization, approximately 50 tons of load at one time can be carried. While the excavation works continued, due to the topographical structure, supporting activities were performed by using very special techniques, and active and passive anchorages were applied. At first, a drill up to 80 meters of the surface was performed, and a steel rope system was applied in the drill hole. Later, by performing grouting works at the root of steel rope system, the steel ropes were anchored to the ground. Then immediately, steel ropes were stretched with 240 tons loads, and the weak ground was supported. The critical geological and topographic conditions of geography provided with 6,415 pieces of anchors with a total anchorage length of 206,178 meters completed in a record time. Following these process, to increase the strength of the surface on the foundation rock under the dam foundation, the joints, vessels, and fractured cracks in the rock were filled, and the consolidation grouting works of the foundation area were performed within the theoretically determined limits, and improvement of the surface parameters were targeted. The data obtained by the geological works was processed on 3D models, and grout take amounts were analyzed, and with the site service continuous verification of grouting works was performed. The foundation rock of Yusufeli Dam was strengthened by consolidation, grouting, and then waterproofing was achieved by curtain grouting through injection galleries. Excavation performed in the excavation activities of the dam since the first excavation in 2013. Excavation materials suitable for concrete are stored in the special stock sites. Even the size of the storage demonstrates the size of the work performed. Materials stored in the storage areas are crushed in 5 different aggregate sizes with crushing screening plants having 200-ton hour capacity and was stored for short time. Aggregate in this was kept to be used for concrete was transferred with an aggregate conveyor line for 2 kilometers according to instantaneous needs. In case of any failure that may occur in this system, 2 aggregate plants were prepared as backup. In other words, the entire system was established on the principle of uninterrupted working to complete the dam on the requested date. Material reaching to aggregate silo was poured into separate divisions according to its size with expansion bearings. In case of a failure, silos were fed with trucks, and in this way, concrete production was achieved for 24 hours non-stop. In these silos you can see behind 12,000 tons of cement and fly ash was stored simultaneously. Special mass concrete used in manufacturing was prepared in this plant. Mass concrete used in dam body is different from normal structured concretes. Mass concrete has a maximum casting temperature. To decrease the concrete temperature increasing during summer and to increase the temperature during winter, this integrated cooling plant installed to keep the concrete temperature at an optimum degree between 10-15 degrees in all seasons. Concrete cooling process in Yusufeli Dam was performed in 2 separate phases: pre-cooling and post-cooling. Before concrete pouring, the cooling process performed during the concrete production is called pre-cooling. Pre-cooling phase was performed at 3 stages. The first stage included cooling process of aggregates with a cooling mechanism which decreases the aggregate temperature reaching 28-30 degree 24 hours basis only in dam body concrete casting. Body concrete was poured into blocks separated as leader and follower blocks. Leading joint blocks consist of upstream, downstream, and side formworks. Follower joint blocks consist of upstream and downstream formworks. There were spherical keys on the side formworks. Upstream downstream formworks placement was performed by placing all panels between EL 440 EL 715 for each block individually. Formworks were used as starter in the first casting. Later they were in climbing form. The cooling system was used for both joint grouting final temperature and crack control. The total length of the 3 cm diameter post-cooling pipes installed in the base of the joint blocks reached 800,000 meters provided from the galleries. Meters and the total length is 4.5 kilometers. Temperature measurement was made from approximately 4,000 points with temperature monitoring devices installed. Other parameters, such as the temperature of each block, reservoir water temperature, and air temperature are also monitored, and the concrete temperature in the dam was continuously kept under control. As the safety of such a building is as important as the construction, the formations of concrete behavior of the body was also continuously measured during the construction and impoundment phase. Recorded measurements were continuously analyzed and the safety of the structure was monitored 24 hours non-stop. Approximately 5,100 measurement devices were placed in total. Of course, the measurements to be made are not limited to these. The single and addition to the load cell systems installed on various anchorages to measure the stress as a standard, Double curvatured horizontal extensometers are also used in Yusufeli Dam for the first time in our country to observe the movements between a few of measurement methods. In fact, Yusufeli Dam is the dam with the most type of measurement devices in our country, with 21 different measurement systems in a total. Yusufeli is the first dam where automatic data collection systems were placed during the construction and maintained automatic measurements, and the name takes part in the literature. With 7 inverted pendulum systems, Yusufeli Dam has the most inverted pendulums in the world. We mentioned that unique engineering solutions are used in the construction of Yusufeli Dam. One of the dam is the installation of the spillway valve chamber transportation platform. Steel platforms prepared in the dam body without stopping concrete activities were assembled to the anchorages left in the body in a short time, and access to the spillway valve chamber was achieved. Structures: the dam body, projected as a thin concrete arch, consists of 29 separate vertical blocks and 92 horizontal lifts. For the crest spillways located on 13, 14, 15, 16, 17 and 18th blocks, starting approximately at the 74th lift, climbing formworks specially designed for each block and joint blocks were used, while elliptical boards and climbing formworks were used in the upstream. The length of the upstream cantilevers of the crate spillway is approximately 36 meters and approximately 7 meters at the downstream. This manufacturing is one of the important examples of the extreme engineering practices applied in this project. With this spillway, it is possible to discharge 106,005 cubic meters of water per second when the dam reservoir is at EL 710 and 2,940 cubic meters of water per second, while at EL 713.5, 2,452 cube water can be discharged in a second, while the reservoir is at the maximum operating level of 713.5. Each of the tunnel spillways is 8.5 meters in diameter, and the total tunnel length is approximately 2,303 meters. A very high-strength concrete lining is required for the tunnels, as the water that will flow from the tunnels, with the tunnel excavations completed, will have very high kinetic energy. In order to prevent cavitation damage that might occur on the concrete surface, 4 ventilations are constructed in the tunnels. To complete the body of the Yusufeli Dam, consisting of 29 separate concrete blocks, 7,000 meter cubes of concrete on average every 24 hours was poured, a total of 4 million meter cubes of mass concrete was poured, and eventually 275 meters height was reached. Considering the amount of concrete poured in the body construction of similar dams, this number can be considered a record. Yusufeli Dam consists of 4 million meter cubes of mass concrete and 1,370,000 meter cubes of conventional concrete, with a total of 5,370,000 meters of concrete, 61,000 tons of reinforcement, and 900 tons of steel. Since the first excavation in 2013, the number of personnel working on the site was over 4,500, even if the numbers different according to the period. This number consists only staff working on the field. In the background, tens of project groups, designers, technicians, the mountain, because there is no area to construct energy structures on the surface. Gate shaft and energy shaft in energy structures are opened using the raise boring drilling method, a special method used for opening of vertical shafts. With the around the pilot shaft with 240 drilling machine was taken up by a mobile crane, and the preparations for blasting started. After the blasting, The crawler excavator was lowered to the surface. Scaling works with the excavator were completed and the energy shaft opening process was completed. The gate shaft drill, which has a diameter of 14 meters and 64 meters long, was completed with the same method and lined with reinforced inlet valves, each with a diameter of 3.8 meters, are located in front of the unit to supply water to the unit in a controlled manner. After the main inlet valve is fully opened, the amount of water to be energized by the turbine wicket gate is determined, and at full speed reached, it is possible to transfer the energy to the interconnected system at the amount requested by the load dispatch center. 3 vertical shaft synchron generators are established with a static warning system. Stator steel carcass, magnetic plates, and windings from the generator were assembled in the assembly and management unit of Yusufeli power plant, and after completing the tests was placed to their place in the units block with power plant cranes with 230-ton capacity. The rotor, which is the most important part of the generator and generates electricity with rotation in 240 rpm in the stator, weighs 320 tons, and it was assembled by laying and compressing the magnetic plates inside the power plant structure and connected the poles, transition zone, and outlet structure. Yusufeli Dam, the final word of Turkish dam engineering, arrived with the excitement and enjoyment like the first day. With backfill concrete in the tunnel spillway outlet area, precautions are taken against possible erosion and scores, and by constructing backfill concrete stages in the side valley, the energy of the water that will flow in the well the peak of Turkish dam engineering.